Hi guys, so today we'll be solving the lead code challenge. It is 3577. So problem says us that we have a complexity array of length n and we are asked to decrypt the computers, and first computer is already decrypted. So at the 0th index we already have an unlocked computer. We need to unlock other computers. Now problem lies that we can only be unlocking other computers if the previous computer is unlocked. First condition. The second condition is that the complexity of the before index should always be lesser than the complexity of the upcoming index. So let's see some examples and then we can start the implementation. So example is 1 2 3. So we know the 0th index is already unlocked, so we can either now we can unlock 2. Yes, we can unlock 2. Also we could have unlocked 3 as well. Rather going to 2, we could have unlocked 3 directly, and after that we have to unlock 2. Can we unlock 2 after 3? Yes, we can. Since 1 is less than 2, we can do that. So we have two ways of doing it: 0 1 2, 0 2 1. Let's check for this case: triple 3, triple 3, triple 4. 3 is unlocked. Yes, it is unlocked. But can we unlock next 3? No, we cannot, because it is not greater, it is equal to. Okay. Okay, but can we unlock 4? Yes, we can always unlock 4, but even if we unlock 4, we can never unlock 3. Okay. So uh, when I saw this problem, what was the first thing that we can see? That is what I saw first. I'll tell you. The first thing that I saw is that we are bound to some indexing. So one thing is sure, that we should not sort the array. First thing. Second thing is that we should always find a greater element. Okay. Now one more observation that I saw is that 0th index is always unlocked. So all elements should be greater than a 0th index. If we found any element which is greater than, which is less than or equal to a 0th index, we should return false. I, false, I mean that it can't be computed, so we can return 0. Okay. So we have talked about negation cases, like when we will get zeros. Now question lies how we will compute the other answer. So let's take an up. Okay. So first we can verify that are all elements greater than and greater than our first element. Yes, all elements. So we will have some answer, that we are sure. Now we need to get all permutations. That means we need to get all ways. Okay. So first place is already taken. So let's spare the first place. Now how many places we do have? 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. If I ask you in how many ways you can fill this place, it's simple. Okay, one more thing: 2 and 2 should be counted separately since we are talking in terms of indexes. Okay. So in how many ways you can fill this place? It is 1, 2, 3, 4, 5. So you can fill in 5, 5 ways. How many ways you can fill the next index? It can be filled in 4 ways. Similarly, 5 into 4 into 3 into 2 into 1. Okay. But how did I came across this approach, or how did I came to this solution? So let's say we have only single array, size is only 1. We'll always have answer as 1. Let's now talk about when size was 2. 1 is fixed, single place we have to fill, only one way is there. Okay. Now let's talk about when size goes 3. How did I came to this solution? This is presented in our normal case as well. So first is fixed, second and third we need to fill. What can come here? Either 2 or 3. What can come here? Whatever is left. So for the middle place we have two options, for the third place we have one option. So 2 times 1, that is 2. Now let's say we have an 4 size array. 1 is fixed, we have 3 options, 1, 2 and 3. What can go here? 3, 2, 3, 4 can go here. Now what can go here? Remaining 2. What can go here? Remaining 1. So what did we observe from here? So what we observe, if the array is correct, that we have already checked on the first step. If the array is correct, then we can just do whatever is our size and take out the factorial. Let's check the code. Code is pretty simple, you guys can already code directly. Okay. Also, since there can be very large number of ways, the question asks us to take modulo. So first we have created a modulo 1e9 plus 7. Then we'll first fix the smallest number. Our smallest number should be r at index 0. Now if we are able to get a lesser number or an equal number to our smallest number, right, then we can directly return 0. Let's say now after this point we are sure that okay, we are getting some answers. Now we have to calculate the answer. So we need to just take out factorial of the size minus 1. I've just taken out size dot minus 1 and I've created answer. How we are doing it? We are just traversing back to 1, fact minus minus, and we are multiplying answer into factorial and always taking modulus. Let's try to run this. Okay, this is accepted. Now let's talk about time complexity. We are traversing first to check if we have found something lesser than or equal. So here we are taking order of n. Now we are again traversing in order of n since we have to calculate factorial. So it's again of order of n. Are we using any other space? No, we are not using any other space. So space complexity is still constant. Thank you guys. This is for this video. We'll connect on the